Thanks, Quinn. Thanks, everybody, for joining. We have an interesting topic today. Today, we're going to talk about pressure vessels. Mainly, we're going to concern with internal linings, as you see in this photo, so protecting the vessel from the inside. We're going to talk about why you would even line a vessel, which is a pretty standard practice nowadays. We're going to go into our Belzona materials. We're going to talk a lot about how to have a successful lining project. Then we're going to go into some case histories and some cool stuff like nozzle inserts. So why even line a vessel? Well, the main thing is you're increasing your reliability. So you've significantly reduced the risk for corrosion of the asset. So with that, you've increased your life cycle. So maybe you had to do an inspection every 8 years or a turnaround every 10 years. Well, now you can extend that inspection every 15 years, instead extend your turnaround every 20 years. So you reduce a lot of downtime, and you also reduce the risk of, severe corrosion happening and, creating an emergency shutdown for repair. So a lot of reduced downtime, and that's huge because I know time is critical. Online time is critical. So you're having a lot of time savings, which is money savings. As far as, that's once you coat a vessel. Let's say you have an infield repair. You have a vessel, you do an inspection, and you realize we need to do some repairs here. We need to protect this vessel to get a longer run on this vessel. Well, the Belzona materials, we have them stocked here in Alvin, ready to go, highly available. So if you needed to do a repair, out of the blue or during an inspection, we can be there with a very limited lead time and be ready to roll and really get a repair as fast as possible, which could give you more time savings, less downtime for the repair. Another big reason why a lot of asset owners use epoxy coatings or internal liners is they're a huge cost benefit over a typical changing to an upgraded metallurgy. So going with the upgraded metallurgy or doing a corrosion resistant alloy cladding. So this is just an example for one project where they had about 40 vessels and they were trying to decide between a Belzona liner or a corrosion resistant alloy cladding. And as you can see in that top row, option 2 was the cladding, option 1 was the Belzona. And the Belzona was, about a fourth of the price. So they saved quite $150 million on capital cost. That's a big time savings for a system that's going to give you that corrosion resistant protective layer. So that's one of the big benefits is your capital cost savings. Down the line though, you're also getting the simpler fabrication, simple maintenance, and they can still be inspected and have an easy inspection strategy. As far as fabrication, a Belzona liner or any internal liner is going to be a lot easier than a clad welding with a corrosion-resistant alloy. Also, since you're using a liner, you don't have to upgrade metallurgy to a stainless steel or a alloy. Your fabrication in terms of welding and machining is going to be easier with carbon. As far as maintenance, if you're looking at an uncoated vessel versus a coated vessel, you're going to have a lot less maintenance over time. So you're not going to have that metal loss over time. You're not going to have to stop production and do a quick repair. You're not going to have a through-wall defect over time because of extended corrosion. So this right here is an example of a coated vessel, and this is 5 years after. So what you've effectively done is installed a corrosion allowance system. So instead of adding more metal for your corrosion allowance, you put a liner. So this is 5 years after. So you've effectively stopped 5 years of corrosion. Most of our liners, when they're fit for service, you're looking at a 10 to 15 lifetime. And that doesn't mean after 10 to 15 years, it's totally gone. That's just our recommended inspection interval. As far as inspecting it during the service life, you can easily do a UT from the outside. If your metal is the same thickness as when the coating was installed, that should mean that the coating is protecting the metal and it's not corroding. So that's a good technique for inspecting the coating without actually opening up the vessel and doing a visual inspection. And finally, the main thing you're looking at is when you coat a vessel, you're just extending the equipment of the life. You're extending the life cycles. Anything you coat, you're just putting a barrier between your asset and the fluid on the inside. So just protecting your asset for a long run. So going into the Belzoni materials, how do we know that our coating is going to be fit for service? Well, when talking to a lot of oil and gas asset owners and petrochemical asset owners and having a conference, these are kind of the most important testing regimes that are out there for internal liners. So the first thing I'm going to talk about is adhesion. So you definitely don't want the coating to delaminate over time. So you need a really strong adhesion. One of the things we do is we do adhesion testings at different temperatures. We do adhesion testing after we do chemical testing, after we do immersion testing. So you really got to know, yes, it has adhesion after it's cured and ambient, but how about at high temperatures? So as you can see here, we do adhesion testing at higher temperatures, and you can see there is a fall off. So you want to always make sure that your coating has some data in those temperature ranges. So how do you know what kind of temperature ranges they can handle? Well, one of the best tests that's out there is called the Atlas Cell Cold Wall Immersion Test. So as you can see on the left here, there's kind of two different ways to do it. If you want it to be a little bit pressurized, you can use a flange system where you flange in. You have two flanges. The inside of the flange is coated with your liner, and then they fill up the pressure boundary with water at a certain temperature. The other one is kind of a glass cell. It's not really pressurized, but you can still get a temperature on it. So then they run this test for about 6 months at a certain temperature that they think the coating should handle, and they test it periodically for delamination, blistering, all types of defects. So for it to be suitable for that temperature, it has to go the entire 6 months without any defects. So as you can see here, there is a change in color, but there's no cracking, there's no blisters, there's no delamination. So that's a pass there. Once it passes the visual test, they'll actually check the coating for resistance. So if it absorbed any water, then the resistance would go down. So it has to pass that test as well. And then they even do an adhesion test after this test, and it has to maintain its adhesion to show that it didn't get any mechanical damage from the heat or from the water. Also, biggest question, all these pressure vessels are going to have some sort of chemicals. Can we handle the chemicals? Well, we do year-long testing. We coat these rods and we immerse them into a lot of different chemicals at different temperatures and concentrations. And for them to have an excellent rating, they have to have no defects after 1 year. So as you can see, these rods on the right here, that would be a fail. So they have some cracking, some blistering, some delamination. So obviously that chemical ate away that coating. So for it to be rated for excellent, which is rated for full immersion, they have to look perfect when they come out, no defects. Also, you want to make sure that the temperature is not going to affect your coating. So these are polymers. So when it reaches a certain temperature, you could get some loss in mechanical strength. So that's what we call the HDT. So above the HDT, it will lose some mechanical properties such as stiffness, tensile strength. You want to make sure it maintains all that because the mechanical properties add to the adhesion. If it loses some mechanical properties, it will lose some adhesion. So you always want to test that as well. And then finally, explosive decompression. So this comes into play after your liner has been in service and you want to, shut down for an inspection or a turnaround. You're going to depressurize your unit. And one issue that could occur is if you depressurize at a certain rate and the coating can't handle it, it could have some issues as far as blistering. Sometimes some gases do permeate the coating, kind of get a little bit into the coating, and when they diffuse out, they can cause a blister. So we pressurize our coatings pretty high, so 100 bar and 212F. And then we do a rapid decompression over 15 minutes down to atmospheric pressure, and they can't have any issues. And we do this with a lot of gases, hydrocarbon gases, and seawater, just to make sure that it can handle that. And then finally, we know that to inspect a coating after it's been in service, you have to put it through a cleaning and steam out regimen. So we do steam out testing to make sure it can handle that as well. So we make sure that it's going to handle the service, it's going to handle the cleaning, and then you can put it back in service once it's been inspected. So now I'm going to go through kind of a coating project. Phase one is typically where we work with our client, figure out what's running through the vessel, what's the temperature, what are the chemicals. We'll look at our testing, figure out what product we need to use, and then we'll put together a specific project specification, an ITP, which is an inspection test plan. We'll put together what are the whole points, who's going to inspect it, who's going to install it, are they trained? If they're not, we can train them. Is it going to be our guys going in there? So we'll put all that together. We'll get all the data, safety data sheets, CRC sheets, which are chemical resistance sheets, and put it all together in a package and schedule it and get it ready to go. Once it's approved, we can move on to phase 2. So phase 2 would be the setup prior to arrival. So scaffolding's a big thing. Sometimes you have vertical vessels and you're going to need scaffolding. Sometimes you need scaffolding on the outside to access some of the nozzles. So, that's the main thing. Every project, usually you're going to need some scaffolding. Airflow, obviously, we're working in confined spaces, so we're going to need some airflow. We're going to need to know what size the manway is, so we know what kind of equipment we can put in there. Nozzles isolated, disconnected, and the vessel decontaminated. So once all that's done, we can start our mobilization phase. Especially in the field, a lot of these jobs are done as new construction, so you can do them, in a shop, which is a little different, a little easier. You don't have to deal with some of the things like the shutdown process. But as far as in the field, even in the shop, you're going to need a climate control system, so a DH and an AC, bringing in dry air into your vessel. So for all that, you will need a generator. We do need to blast the surfaces to get our profile and surface cleanliness requirements. So we're going to need a compressor, blast pot, hoses, and our blast media. Then, of course, we need our Belzona materials, so our Belzona product. Sometimes we do apply this by airless spray, so we'll need to bring in our spray rig. So there's a lot to set up. That's usually a day or two to get everything set up, get familiar with our pressure vessel, do an inspection, kind of get a plan to go ahead, because there are times when that's the first time you've seen the inside of this vessel. So a lot of times when you're shutting it down in the field, you don't really have a chance to see it until you start your project. So this is where the pre-surface preparation comes in handy. You can go in there, take a look at the vessel. Maybe you found that there's more pitting than you thought. Maybe there's less pitting than you thought. Look at all the welds, see what needs to be stripe coated, make a plan. And then one of the main things of the pre-surface preparation is, even though the vessel's been decontaminated, steamed out, cleaned out, sometimes you do have some salts within the metal. And one of the big things is you want to check that. So that's what this picture is here. It's checking there's 16 milligrams per meter squared of chlorides. Our limit is 20, so we were good here. You want to make sure you're under the limit. That way you can blast and not have to worry about any flash rust, and also any blistering during the application. If you do apply it with high salts, there is a chance for blistering over time. So if we do find that it's high, we'll desalt it before we start blasting. And that's usually a whole point with the inspector. So we got our mobilization, we're set up, our vessel's decontaminated and desalted. This is really when the application process starts. This is when everything has to be done kind of boom, boom. You don't want to wait too much in between steps. So the first step is to get your surface preparation done. So any internal liner, we're gonna need a blasting to near white metal. So that's a clean blast, removal of all rust scale, mill scale, down to bare metal with a 3 mil anchor profile. So as you can see here, we're blasting. This does end up in a lot of blast media being made. So one of the big things is you want to have a vac truck ready once you're done blasting to suck out all this media as quick as possible. Clean your vessel. This does bring a lot of dust out, so you have to do a solvent clean, vacuum. You want this metal to be pristine, just clean, no dust, no media, nobody sweating in there. So that's one of the big things we tell people is, once it's blasted, you're going to have a clean kind of operation. Everyone's going to wear shoe covers, coveralls. One of the big reasons to have AC too is to keep it cool so people aren't sweating in there, because that could lead to flash rust. So it's really big to have climate control, QA, QC documentation throughout showing that it is climate controlled and you got your profile and you got your cleanliness So this is going to be a whole point after this. So and this is what a near white metal blast would look like. Clean metal with like a rough anchor profile. That's going to give us our best adhesion. So once you've done the desalting and the surface preparation, you have it blasted and you have that vessel cleaned out, that's a good, you've reached a good level there. That's always kind of, now it starts to flow pretty good. No more heavy lifting. Now it's just, let's coat it. So the first thing you usually do is, if there's any pitting, you're going to pit fill with our rebuild products. There's nozzle inserts and there's stripe coating. Normally those are all done at the same time. You have a 3-man crew, 4-man crew, you kind of attack those all in one day. So stripe coating is what you're looking at here. That's an additional coat to any hard to reach areas, any welds and sharp corners. Sharp corners and welds, you tend to need a little bit more film buildup to avoid having pinholes. So those areas would kind of require an extra coat. Pit filling, if you have any pitting, you want to smooth it over with our rebuild paste grade materials. Then any nozzles, there's always a lot of nozzles on the pressure vessels. Any nozzles 3 inches or below OD, it's really hard to coat those properly. So there's, you can stick a blast nozzle in there and then, coat it as best effort. But the only way to really get 100% coverage guaranteed is with our nozzle insert system. So on the top picture, this tube right here is actually made out of Belzona. You blast the inside of the nozzle and you apply material to the inside of the nozzle and to the outside of the Belzona insert, and then you stick it into the nozzle. As you can see here, he stuck it in from the outside and it protrudes a little bit. Once it's dry, you can cut it flush with the vessel and then taper it and bevel it down to the flange or to the vessel wall. So that gives you 100% coverage of the nozzle. Nozzles are an area that tend to be the failure points. So this is a system that increases the reliability tremendously. So once you've done your pit fill, your nozzle inserts, and your stripe coating, you want to keep in mind that you have a blasted vessel. So you want to do this in a timely manner, and you want to get your first coat on as soon as possible, because that freshly blasted surface has a limited time to where it would flash rust, especially in the field and especially a vessel that's been in service. So you want to get all this down, and as soon as it's tacked up and ready to go, you want to get your first coat on. So this would be our first coat. Now, once you put on your first coat, you kind of breathe easier a little bit, just because you've applied your first coat, you put it on a nice blasted surface, and you don't have to worry about flash rust at this point or having to do an extra blast. So this is when you can kind of breathe easy for a second, but you also got to keep in mind that every coating has an overcoat window. So for example, this one has a 24-hour overcoat window. So I have 24 hours before I need to put the second coat on within 24 hours. And it takes about 4 to 6 hours to dry. So you really want to time it, later in the day, so that the next morning you can come in the morning and get that second coat on. That's what we typically do. Get our blast done early, stripe coat, and then later in the day, we apply our first coat, and then in the morning, the second coat. So you just got to plan that out, because a lot of times you have to walk on that first coat. So it has to be dry enough for you to walk on, not like this scenario where you don't really have to walk on it. And so all steps should be applied within the overcoat window. And typically for each one of these steps, there's a hold point. So that's another thing to keep in mind. Keep your inspector in the loop. Tell them, hey, we're about to stripe coat. We're going to be done in 30 minutes. So you can come and look at it. Hey, our stripe coat's set up. Everything's ready for the first coat, because you can have some time in between, and time is just very precious during these applications. Finally, once you have your 2 coats on, that's when you can almost breathe a little easier, but that's when the fun part comes, which is the inspection. So with internal liners, it's a very particular process. I mean, they really have to be perfect. So you literally check every square foot for pinholes with this holiday detector that you're looking at here. So this, you drag it along the surface, and if there's any pinholes, it'll make a spark or a beep. So you have to check for all those, mark them. There's always going to be a couple here and there. And then you also this video here. So right here, I'm checking for the dry film thickness. So every coating has a specific thickness that you have to reach. So you have to make sure that you're within that thickness. If you're below the thickness, you have to mark that spot and add additional coating. If you're above that maximum thickness, then you have to sand it down and get it below the maximum thickness. So pretty much you have to have a perfect liner for every system. That's what gives it the increased reliability, is that the QA/QC process during the application is what gives you that increased reliability. And finally, you do it all right. Always tell our clients, just make sure it's cured. I mean, there's no point of going through that whole process and putting it into service too soon. There are ways to make it cure faster via force cure. So for some application we had last year, we put in 150-degree heat with a heater, and we decreased the cure time by almost half. As you can see in this completion of the molecular reaction, you can significantly make your coating cure faster with some added heat. So going into some examples, we do a lot of different pressure vessels, a lot of hydrocarbons. So this is a high pressure, low pressure separator, knockout drums for offshore. Temperature range from about 150 to 200 F, and the operating pressure from about 150 to 600 PSI. Like I said, it's just a hydrocarbon and water mixture. For a lot of these vessels, they typically coat the bottom, kind of like for desalters and water separators. The water tends to settle on the bottom, so that's where most of the corrosion occurs. So you don't always have to coat the whole vessel. You're not going to have any corrosion at the edges. It can handle itself and protect the areas that need to be protected. Kind of same idea here, just the bottom of an electrostatic desalter. So fairly large vessel here. So coating just this half saves a lot of on the budget. This one, they coated the whole vessel, amine stripper. So we definitely have a lot of solutions for amines, and this is probably one of our most coated pressure vessels is for amine pressure vessels. So this one had MEA. Of course, you're most of the time you're going to be stripping H2S and CO2, so that's going to be the corrosion mechanisms within these vessels, so we can handle those chemicals as well. So amine reboiler. As you can see, this one has been in service, but it was done kind of at a shop. For this one, you got to decontaminate. You're probably going to have to desalt, clean it really good, and then pit fill it. Not much stripe coating required here. First coat, second coat, and that's your system. This one was operating at 302. Amine flash drum. Again, this is kind of off-site, so it's a little easier to get your climate control, and it's a little bit faster, without having to go into the plant. Usually there's always a little more time when you're working at a plant. So now this one's in the field. This is when it gets a little bit more tough. You just have to really have your scheduling down pat. You really have to make sure your climatic control is working. There's always times when your generator might go down, or your AC stops working for some reason. So you want to have operators kind of check throughout the night and make sure that AC is still on. That's happened to us before. You come to the field the next day, your AC shut off midday, so you lost your climate control. So you want to keep track of what's going on overnight. Blast media cleanup, a little tougher, especially you want to get everything timed with the vac trucks and make sure you clean up that blast media as soon as you can. And then just scheduling, sometimes for shop jobs, we can have a day crew and a night crew, which makes it a little faster and makes it a little less close to overcoat windows, but it's tougher to do that in the field. So just want to keep in mind when you're working in the field, things that you have to deal with. So, and we've also done, it's not always, coating every part of the vessel. For this one, it was a couple of trays were having issues underneath the trays. About 10-foot section in height was suffering the most. So we coated that section. This one was just the bottom half was having issues. So we coated the bottom half. This is a particular one here. They actually had a Halar coating with a rubber liner underneath, and it was burned during the upset. So this is one that's more like a repair. So we came in and just did a localized repair. This rubber liner was about a 1/4 inch thick. So we used our paste grade material to make it flush with the Halar coating. That's what they requested. And then we apply 2 coats of a system that can handle what was running through the pressure vessel. And here is just another bottom half where the water kind of settled. This was a water separator, gas water separator. They coated the bottom half. And all you're doing here is just protecting your vessel, isolating it from the fluid, and giving yourself some extended life. So you might have hit a corrosion spot where you're not going to make it to that 2023 turnaround, but if we coat it, we can easily make it there and probably go past it. So that's the main idea. A lot of clients just choose to, on the new construction, coat it, and that's going to really extend the life. You're never going to see that corrosion, and you're just protecting your asset from the start. But we can also rebuild it once it's seen that corrosion. So that's about it for this presentation. We definitely do a lot more with pressure vessels. Some of the problems we've been seeing more than internal corrosion is actually CUI and external corrosion. So we definitely have a lot of solutions for that as well. That will be another week. We've talked about CUI and we've done external corrosion. But if you have any questions, let us know. And if you want to do a specific presentation where we can have more of a conversation, you have a specific application you want to talk about, we can definitely do that. This